Okay, let's talk about complex numbers and roots. Day 2. We have to go through some details first, just some definitions and explanations before we work through some problems. First of all, a complex number is a number that can be written in the form a plus bi, where a and b are real numbers. Real numbers are like 1, 2, 3, 4, 5, 1.2, 1/3, etc. And I is the square root of -1. The set of real numbers is a subset of the set of complex numbers C. And all this means, this part, is the charts that we went through very early on in the school year. Every complex number has a real part, A, and an imaginary part, B. Okay, and in beginning examples, our real parts are always going to be red, and our imaginary parts are always going to be B. So a complex number is A plus BI. Okay, and an example. We're going to do some equations with complex numbers. Find the values of x and y that make the equation true. So the first thing we do is write the equation down, which you see right here. We have the real parts, which is the A plus BI, the imaginary parts, and that should be blue too. So we're going to set the red parts equal to each other. 4x equals 2. Divide by 4, divide by 4, x equals 1/2. And then we're going to set the blue parts equal to each other. 10. We don't need the i's because they would cancel out anyway. Alright, divide by -4, divide by -4, y equals -5/2. Okay, let's try. Same type of equation. Find the values of x and y that make each equation true. Okay, these are the real parts. So I'm going to go ahead and say 2x equals -8. And these are the imaginary parts. -6 equals 20y. Divide both sides by 2. X equals -4. Divide both sides by 20. Y equals, let's simplify that, -3/10. Okay, just a silly exercise. Okay, you try this one. Okay, it looks a little different, but I know you guys can do it, so push pause and try on your own. Okay, the square root of 6 hopefully didn't confuse you. You just treat it like all the other problems. Okay, now we're going to use this information that we've learned. Find the complex zeros of the quadratic functions. We're going to complete the square and solve this equation. So if you remember completing the square, I'm going to set this equal to 0. That's a 26. I apologize, I don't have a stylus, which is awfully painful. Set it equal to 0. Subtract 26 from both sides. Now I want to add my box. Okay, in the box goes b over 2 squared. I'm going to erase the box because I'm going to have a really hard time writing inside of it. b over 2 squared, which is 10 over 2 squared. 10 over 2 is 5. And apologize, there we go. 10 over 2 is 5, 5 squared is 25. Okay, complete the square. I'm going to get x plus 5 quantity squared equals -1. You see where we're going with this? Excuse me. X plus 5 equals plus or minus I, because the square root of -1 is I. So x equals 5 plus or minus I. Okay, look that over again. Make sure you understand. Let's try another one. Find the zeros of the function. I'm going to set it equal to 0. Okay, I'm going to move over here a little bit. Subtract 12 from both sides. Okay, complete the square. I'm going to add b over 2 squared. So that's 4 over 2 quantity squared. Add 4 over 2 is 2. Quantity squared is 4. That gives me x plus 2 squared equals negative 8. Looks like we have another negative. Square root of both sides, x plus 2 equals square root of negative 8. Okay, let's deal with that square root of negative 8. 8 is 2 times 4. So that gives me 2 square roots of negative 1 times 2. Keep on simplifying. I get 2i square root of 2. I still have this over here. Subtract 2 from both sides. My answer is negative 2 plus or minus 2i square root 2. Okay, that was a little tricky. So look it over and make sure you understand all the steps. Okay, why don't you try this one? Push pause. Okay, there you go. We completed the square, had a negative 9 on the right side of the equal sign, but it worked out. Try another one on your own. Push pause. Okay, there you go. We have one more thing to change colors for a sec. This right here, I'm going to read that. X equals 4 plus or minus I square roots of 2. Okay, I'm going to do a little aside here. With the problems we've done in the past, sometimes you'll get something like 3 plus or minus 2. That's the same as 3 plus 2 and 3 minus 2. So we get 5 and 1. Okay, that's a pair of things, and what we have right here is a pair of things. Let's go back. Okay, this one's actually simple as long as you just pay attention for a little bit. So in each slide, I'm going to go back one. So these are actually called complex conjugates. If you look right here, negative 5 plus I square roots of 10 and negative 5 minus I square roots of 10 are related. The solutions are complex conjugate pair. Their real parts are equal and their imaginary parts are opposites. Real parts are equal, imaginary parts are opposites. The complex conjugate of any number a plus bi is the complex number a minus bi. They're pairs. If a quadratic equation with real coefficients has non-real roots, the roots are complex conjugates. Okay, they always come together. If you see one, the other one's there. When given one complex root, you can always find the other by finding its conjugate. So, simply saying, we're finding the complex conjugate. Our problem is 8 plus 5i. The complex conjugate is 8 minus 5i. Rocket science, I know. So if we have b, it's really 0 plus 6i. The complex conjugate is 0 minus 6i, or just plain negative 6i. That's the complex conjugate. That's the complex conjugate. Last thing, you try these, okay? Rocket science, you can do it. Check it out. That's it. We're done.